Hello students, welcome to Marine Engineering Tutorials. I'm Atul Kumar Gupta and back with a new tutorial. Presently we are studying marine auxiliary systems and deck machinery. Today we have 24th lecture and will discuss the following topics. In this tutorial we will first learn about the safety devices equipped on air compressors and their purpose. Then we will learn about the construction and operation of relief valve. Next we will learn about the construction and operation of bursting disc. Then we will learn about the construction and operation of low lubricating oil pressure trip. Next, we will learn about the construction and operation of high air temperature trip. Lastly, we will learn about the automatic operation of air compressors. Let's discuss these through the following slides. Safety devices equipped on air compressors. For safe and reliable operation, air compressors are equipped with following safety devices. Relief valve for each stage. Regulations require fitting of relieving devices on the high pressure stage, but the common practice is to fit a relief valve on each inter and intercooler. Relief valves do not allow the pressure to rise 10% above the maximum working pressure. Bursting disc. Bursting disc prevents the buildup of pressure in the cooling water chamber and subsequent damage due to rupture of air cooler tube. Low lubricating oil pressure trip. For safeguarding the air compressor against loss of lubricating oil pressure, a low lubricating oil pressure trip is provided. It is a pressure switch which shuts down the compressor when lubricating oil pressure drops below the preset value. High air temperature trip. High air temperature trip is equipped on the delivery air pipe. It is usually set to trip the compressor at 65 degrees Celsius to prevent the seizure of piston in the liner due to failure of cooling water. Relief valve. The sketch shows the construction of a relief valve which is described below in order of its assembly. Relief valve consists of a valve body having external threads for mounting on inter or outer cooler and provides a passage for high pressure air. On the upper end, it also forms the seat for the valve disc. Valve cage is screwed to the valve body which has relief holes to discharge the air to atmosphere and limit the compressed air pressure in each stage. A Teflon disc is attached to the spindle which rests on the seat and maintains the pressure until it exceeds the set limit. A heavy spring keeps the valve closed whose tension is set by the compression nut. A cap is secured on the valve cage and sealed to prevent unauthorized change of relief valve setting. Bursting disc. The sketch shows a bursting disc arrangement which prevents the buildup of water pressure in the cylinder jacket due to the rupture of air cooler tube also housed in the jacket. The ruptured disc is in the form of thin metallic or rubber sheet secured to the compressor jacket. A protection cover surrounding the ruptured disc is attached to the compressor jacket with mounting screws. When the disc ruptures, the protection cover directs the water downward and prevents damage to nearby machinery or injury to operating personnel. Bursting disc ruptures at the set pressure and must be renewed after the tube leakage has been rectified. Low lubricating oil pressure trip. This sketch shows a low lubricating oil pressure trip which safeguards the air compressor against loss of lubricating oil pressure. This pressure switch shuts down the compressor when lubricating oil pressure drops below a preset value. Pressure switch is equipped with two sets of contacts, normally closed between 1 and 2 or normally open between 1 and 3. These pressure switches may be used for different purposes. Normally open contact is used for low lubricating oil pressure trip as shown in the sketch. Pressure switch consists of a diaphragm or bellows which moves under the oil pressure and makes or breaks the electrical contact. Pressure can be set by changing the spring force with the help of adjusting screw. Compressors' usual lubricating oil pressure is between 2 to 3 bar. Pressure switch is set to trip the compressor when lubricating oil pressure drops to 1 bar. Air compressor is equipped with an attached lubricating oil pump driven by its crankshaft. When the compressor is started, it takes few seconds to build up the oil pressure. For preventing the damage to bearings during the absence of lubricating oil in the beginning, the compressor is operated in the unloaded state during this period. To enable the startup of compressor, a delay timer is used during the unloaded period for about 10 seconds, which makes contact through A and B. The trip remains bypassed during this period. When the lubricating oil pressure is established, the diaphragm moves up along with the plunger by compressing the spring. The common terminal breaks contact with 2 and makes with 3. On completion of the delay time, the contact A and B is broken and C and D is made. Now the trip starts monitoring the lubricating oil pressure. If the oil pressure drops, spring pushes the diaphragm, thus breaking the contact between 1 and 3 and the compressor trips. High air temperature trip. The sketch shows a high air temperature trip equipped on the delivery air pipe, usually set to trip the compressor at 65 degrees Celsius. Cause of the trip may be found air cooler tubes, insufficient cooling water due to faulty pump or too long operation of the compressor. It consists of a thermostat which works on the similar principle of a pressure switch. It has a fixed pressure connection in the form of sensing bulb attached with a capillary tube. A highly expansible fluid is sealed in the sensing bulb which exerts its pressure on the operating bellows through the capillary tube. Increase in temperature increases the pressure and inflates the bellows and vice versa. Force of actuating spring is set by the adjusting nut which opposes the movement of bellows. Movement of actuating plunger makes or breaks the contact. Thermostats are equipped with normally open and normally closed contacts used for different applications. Normally closed contact is used during compressor operation. As the temperature increases, rise in pressure expands operating bellows which lift the operating plunger. At the set point, the contact between common and normally closed is broken and the compressor trips, which also activates the alarm for drawing the attention of duty engineer. When high air temperature trip activates, it needs to be reset manually to find the cause of malfunction and subsequent rectification of the fault. Automatic operation of air compressors. The sketch shows a shift arrangement of automatic control circuit for starting and stopping the air compressor. Ship is equipped with two air receivers and two compressors driven by electric motors. When the ship is at sea, one set of compressor and receiver is in use with the concerned valves open, while the other is kept pressed up and remains standby for use in emergency. It can be seen from the sketch that compressor number 1 is selected to start and stop automatically, whereas compressor number 2 is set on manual operation. Compressors are started and stopped automatically by their respective pressure switches. When the pressure in receiver number 1 drops to 22.5 bar, pressure switch cuts in the compressor number 1. Starter panel keeps the unloader open for few seconds so that lubricating oil pressure is established before loading it. When drain valve closes, pressure starts to build up until 30 bar, when pressure switch cuts off the compressor and the drain valve are opened. During the shift maneuvering, engine starting gear requirement is considerably high, which requires both the compressors to be used on automatic mode. If the pressure in the starting gear receiver drops to 18 bar, pressure switch starts compressor number 2. When the pressure reaches to 27 bar, pressure switch cuts off the compressor, whereas compressor number 1 will continue to work until pressure reaches 30 bar. When the pressure in the operating receiver drops below 12 bar, standby receiver can be used for engine movement. This completes the study of safety devices equipped on air compressors and their automatic starting and stopping procedure. This book is written by me and covers all topics as per the syllabus specified by Indian Maritime University. It clarifies the concepts with simple illustrations. The book also provides answers to all the questions which have appeared in the examination conducted by Indian Maritime University. The book can help the students in preparing for the exam and also to work on ship's auxiliary systems and deck machinery safely. Hope that you have liked the lecture. You can write your feedback in the comment box. If you have liked the tutorial, you may share it with your friends. You may subscribe to the channel for getting notification about the new tutorials. I'll be back with a new lecture shortly. Thanks for watching till the end.